not be at school again today when you're watching this, October 24th, for first and second period. So I wanted to touch base with you guys on a few things. First of all, you have a test retake will be in class Wednesday. So this Wednesday, October 26th. I did offer to all of you a chance to come during fifth period if you wanted to, in lieu of the pep rally, to go over your test. I understand if you did not want to do that. You can come back today sometime between third and sixth period in between classes if you want to get a copy of that test. And also, if you want to come back today and you have an elective anywhere between third and sixth period and go through the lesson on lesson 4.1, I'm available to do that. So you can return to just pick up your Chapter 3 test. And if you have elective, you can come back today, periods 3 through 6. I will be teaching lesson 4.1. You guys actually had the opportunity to watch the video in class on Friday for lesson 4.1 and start working on the homework. So I am going to go through all of the problems in lesson 4.1, and then the sub will play this in class Monday morning. So the first thing you had to do is you had to match the triangle description with the most specific name. I am actually doing this without answers right as I record. So we're going to go through these, and if I make a mistake, I'll go back and fix it. So the first one, angle measure of 30, 60, 90 degrees. That is definitely going to be a right angle, and we'll see if there's a better name. Side lengths of 2 centimeters, 2 centimeters, and 2 centimeters. So all the side lengths are equal. That is equilateral triangle, okay? Angle measures of 60 degrees, 60 to 60 degrees is equal angular. Now you also notice there's 2 E's here. Oh, that actually says F. I thought that said E though, because my point was going to be, as we'll learn later, if a triangle is equilateral, it also is equiangular. And if it's equiangular, it's also equilateral. So side lengths of 6 meters, 3 meters, and 6 meters means that 2 sides are equal. That is an A, isosceles triangle. 5, 7, and 9. None of the side lengths are equal. That's a scalene triangle. Now sometimes, as would be the case here, if we actually found the side lengths of triangles that did 30, 60, 90 degrees, we would find that it also is a scalene right triangle. That's more than we have learned yet in this lesson. So right now we know that 30, 60, 90, all the angles are different, but one of them is a right angle. And for side lengths 5, 7, and 9, all of them are different. That is scalene. Angle measures of 20, 125, and 35 degrees. Once one triangle has a measure of greater than 90, it is obtuse. And then writing. Can a right triangle also be obtuse? The answer is going to be, and I'll type it here. First of all, it's no. Because if one angle is 90 degrees, the measure of the other 2 angles has to add up to 90 degrees. This is because the triangle Sum Theorem tells us that the total sum of the measures of all of the angles is 180 degrees. So basically, once one angle is 90 degrees, the other two are going to have to add up to 90. So the other two are obviously going to be complementary. A right triangle can also not have an obtuse angle. So now we're going to, it says copy the triangle and classify it by its sides and its angles. So its sides are scalene, isosceles, or equilateral. This has two sides that are the same, so it's isosceles. And then when we talk about its angles, that's either right, acute, or obtuse. It's a right triangle because one angle is right. Okay? For M, all of the sides are equal, so it's an equilateral triangle. That also means all of the measures of the angles are equal. When it's equilateral triangle, it happens at all the measures. They have to all add up to 180. So it's going to be acute, but each angle will equal 60 degrees. In an equilateral triangle, that means it's also equiangular. All of the angles are going to be the same. Since they have to add up to 180, they can only be 60. On JKM, nothing is labeled as congruent, no sides, so it's scalene. And it looks to me like angle K is obtuse, so it is obtuse. For problems 11, 12, and 13, you're told to graph them and then classify it by its sides and determine if it's a right angle. But I don't think that is the best way to do it because you don't always get graph paper. So what you want to be able to do here is understand that you are actually finding the lengths of three sides. Then when you find the lengths of each side, you can figure out if it is isosceles, equilateral, or scalene, and then you also are going to find the slope. So for instance, let's look here first at side AB. And this is all going to be radical. I'm going to type so you can see what I'm doing a little bit better. But I'm going to do the square root of 2 minus 6, which is 4, quantity squared, which is 16, plus 3 minus 7, which is negative 4, quantity squared, which is 16. So 16 plus 16 is 32. So your length is radical 32. You don't really have to worry about how long radical 32 is, just a matter of if it's the same as something else. So that was AB. Now we're going to look at BC. So 6 minus 2 is 4, quantity squared is 16, plus 3 minus 7 is negative 4, quantity squared is 16. So BC is radical, or the square root, of 32. So right away, I can see that AB and BC are congruent, so this is at least an isosceles triangle. Now I'm going to look at AC. 2 minus 2 is 0. 0 squared is 0. Plus 3 minus 7 is negative 4. Quantity squared is 16. So AC is radical 16, which is 4. That means that right now, this is certainly isosceles. Now you have to figure out if it's right or not. The way you want to figure out is right is figure out the slope of each of these lines and see if you have anything that is negative reciprocals. So the slope of AB would be 3 minus 3, which is 0, over whatever it is going to be 0. Now the slope of BC is 3 minus 7, so that's negative 4 over 6 minus 2. Negative 4 over negative 4, so the slope is equal to 1. And for, move this up a little bit, for AC, slope is 3 minus 7 is negative 4 over 2 minus 2, which is 0. So when you have a 0 in your denominator, it's undefined. So since AB has a slope of 0, that's a horizontal line, and AC has a slope undefined, that's a vertical line. So 0, so we're going to remember that a slope of 0 and a slope of undefined are considered negative reciprocals. So it is isosceles, and it is right. Okay. Now we're going to go ahead and do number 12. So I'm going to go back up here, and I'm going to go and do AB first. So AB is the square root of 3 minus 6 is negative 3, quantity squared is 9, plus 3 minus 9, quantity squared is 3 minus 9 is negative 6, quantity squared is 36. So AB, and remember everything should have a square root sign, is a radical 9 plus 36, so that's radical 45. Once again, it doesn't matter what radical 45 is, we want to see if anything is equal here. So now we're going to go to BC. 6 minus 6 is 0. 0 squared is 0. Plus 9 minus negative 3. So 9 plus 3 is 12. Quantity squared is 144. So BC would be radical 144, or square root of 144. So BC is 12. And now let's look at AC. So 3 minus 6 is negative 3. Quantity squared is 9. I don't know why it got little, but we'll deal with that. Just make sure I did that right. 3 minus 6, negative 3, quantity squared is 9. 3 minus negative 3 is 3 plus 3 is 6, and that's 36. So right away I can see that AB and AC are equal again. In length, BC is not, so 12 is isosceles. And we're going to look at slope to determine if anything is perpendicular. So for the slope of AB, 3 minus 9. 3 minus 9 is negative 6 over 3 minus 6 over negative 3. So slope is positive 2. Negative 6 divided by negative 3 is positive 2 for BC, for the slope. 9 plus 3, because 9 minus negative 3 is 9 plus 3 is 12. 6 minus 6 is 0. So our slope is undefined. And then moving this up here, AC equals 36. 3 minus negative 3 is 3 plus 3. So that's 6 for the change in y in the slope over x. 3 minus 6 is negative 3. So the slope is negative 2. That is not the reciprocal here. So they're the same. One is a positive 2, one is a negative 2. That's not reciprocal, so it's isosceles, and it's not right. I'm going to just double check that real quick because there was a lot of work there. I'm going to make sure I did that all right. So that was 3 minus 6 is negative 3, 9, 3, and okay, so that looks correct. All right, and now we're going to go ahead. Having some technical difficulties here with the typing, and do the last one. So for AB, length 1 plus 4 is 1 minus 4 is negative 3 squared is 9 plus 9 minus 8 is 1 squared is 1. So AB is the square root or radical 10. BC. 4 minus 2 is 2 squared is 4 plus 8 minus 5 is 3, and then 3 squared is 9. So BC is a square root or radical 13. And then for AC, 1 minus 2 is negative 1, quantity squared is 1, plus 9 minus 5 is 4, quantity squared is 8. So right away, none of these, well, let's finish this up here. AC is radical 9, so AC is 3. None of these lengths are equal. So once again, what we do is we find the length of AB, the length of BC, the length of AC. None of them are equal, so it's scalene. Now let's look at the slope. I'm just going to do this over here, have a little more room. So the slope of AB, your change in y is 9 minus 8 is 1. Your change in x, 1 minus 4 is negative 3. So AB, your slope is negative 1/3. BC, 8 minus 5 is 3. 1, 8 minus 5, 4 minus 2 is 2. So that is not a negative reciprocal of anything. A, B, and BC are not negative reciprocals. Let's look at AC. 9 minus 5 is positive 4. 1 minus 2 is negative 1. So none of these are negative reciprocals. It is scalene, not right. Now, once again, the homework actually said to graph them, and obviously if you have graph paper and you look at it on graph paper, it'll be easier, but I really wanted to take the time here to practice with you how to do these, finding the length of each segment, because we need to practice distance formula, and finding the slope to determine if the lines are perpendicular. Okay, I was charging my slate and now it looks like it has completely died. I'll figure out what I'm doing at school. It should be fun. Not really, but let's go ahead and look at some of these problems. Continue to look at these problems. I'll just type. So find the value of x, then classify the triangle by its angles. And it looks to me, it's a little difficult to see that that's 60, 60. They have to add up to 180. So right away, 180 divided by 3 is 60. So for number 14, x is equal to 60. And since they're all 60 degrees, it's an equilateral triangle. Technically, if we're measuring it, classifying it by angles, it's equal angular. But in triangles, when it's equal angular, it's also equilateral. So number 15, we're going to have x plus 3x plus 60 equals 180. X plus 3x is 4x. I'm going to subtract 60 from both sides. I get 120. That means x equals 30. So if this is 30, and that's 60, 30 plus 60 is 90, 180 minus 90 means this last angle would hopefully be 90 degrees, and 30 times 3, check that there, is 90. So for number 15, I'm supposed to classify it, and it's a right triangle. For number 16, this is exterior angles theorem, where the exterior angle is equal to the sum of the two non-adjacent interior angles. So let's just say this here said angle y. Angle y would be my adjacent angle to angle x. My non-adjacent are 70 plus 64. And that's going to equal x. Because once again, the exterior angles theorem says the exterior angle is equal to the sum of the two non-adjacent interior angles. So 70 plus 64 is 134 equals x. So if x is 134, they didn't ask us to, but this y would be equal to 180, because they make a linear pair, minus 134, which would be 46. Okay? For number 17, find the measure of the exterior angles shown. So once again, in these cases, the exterior angles, so for instance, number 17, 2x minus 2 is the exterior angle. It's going to be equal to the sum of the two non-adjacent interior angles. So 2x minus 2 is going to be equal to x plus 45. I'm going to subtract x from both sides. Do this like this so you can see what I'm doing. So 2x minus x is x. Bring down the negative 2 equals 45. Now I'm going to add 2 to both sides, and I get x equals 47. Now I can check this. So if that's 45, that's 47. Now this would be, if I wanted to find that angle, 2 times 47, so 47 times 2 is 94 minus 2, so that should be 92. That's the exterior angle. The exterior and the interior make a linear pair. They should add up to 180. So 180 minus 92 is 88. So I have it. That they didn't ask me to find that, but I'm doing this so I can check my work. I'm finding more than I need to find here. So 88 plus 47 plus 45 equals 180. So that's how I can check my work and make sure I did it correctly. For number 18, my exterior angle is 3x plus 6. My non-adjacent interiors are 24 plus 2x plus 18. So my non-adjacent interiors are going to add up to my exterior. That's exterior angle theorem. So I can't combine anything here yet. I have 3x plus 6 equals 24. Just going to do it on here so you see exactly what I'm doing, even though you should be able to do this in your head. Whoops, but obviously I need a calculator because I can't even type it right. 24 plus 18 is 42. And we have 42 plus 2x. We're going to subtract 2x from both sides. So 3x minus 2x is x. Bring down the 6. 42 minus, okay, because we subtracted 2x from both sides. Now we're going to subtract 6 from both sides. And 42 minus 6 is 36. So let's check this out. Here, we have 2 times 36, which is 72, plus 18 equals 90, which is good because it actually looks like a right angle. Look at that. It's 90. That's 24. So over here, 3x, so 36 times 3 is 108, plus 6 equals this exterior angle is I don't know why I can't get rid of that t, so I'm just gonna ignore that t. It won't go away right now. So if that's 114, the interior angle here, they did not ask me to find it, but I want to find it to check my work, is 66. So now 66 plus 24 is 90, plus 90 equals 180. So for problem 18, my work checks out. And for this one, they want to find angle 1. But I know that 90 plus x plus 3x plus 2, since they're all interior angles, is going to add up to 180. Since one of these is right, I actually know that the 3x plus 2 plus x is going to equal 90 because they're going to be complementary. That means 3x plus x is 4x. I'm going to subtract 2 from both sides. I get 88. Dividing by 4, that means x equals 22. Okay, so if x equals 22, 3 times x, 22 times 3 is 66, plus 2 is 68. 68 plus 22 plus 90 is 180. And x and angle 1 are a linear pair, so 180 minus 22 is 158. Okay? And explain how to use the corollary to the triangle sum theorem to find the measure of each angle. We kind of just did that here. The corollary said that since this is a right triangle, the two acute angles, so 3x plus 2x, which is 5x, are going to add up to 90. And then 90 divided by 5 is 18. So this is 36. 3 times 18 is 54. And 54 plus 36 is 90. Now they want to find the measure of the numbered angles. They want to find all of these. So I'm just not necessarily going to go in the order they want me to. Maybe I will. So let's see here. So we're going to start out here. This is a triangle. Angle 1 is an angle. This is 90. This is 40. So using the corollary, 40 and the angle 1 are going to be complementary. So angle 1 is 50 degrees. Okay. That also means angle 3, I'm just going to jump ahead here, is 50 because they're vertical angles. 1 and 2 make a linear pair. So 2 is going to be 130 because a linear pair means they're supplementary. So 50 plus 130 is 180. If angle 2 is 130, angle 4 is 130 also because they're vertical angles. So now, if angle 3 was 50, then angle 5 has to be 40. Because 50 plus 40, they're complementary, makes 90. Now there's two ways, so now we're looking at 6. So if this was 20, and we already found 4, which is 130, 20 plus 130 is 150. 20, angle 4, and angle 6 have to add up to 180. So once again, I just said 20 plus 130 is 150. 30 more for angle 6 would get you to 180. Problem 27. In triangle PQR, P is equal to R, and the measure of X is twice the measure of R. So find the measure of each angle. So I'm going to say P for one angle, and since P is congruent, I said equal to, but congruent, that's going to be another P. So R can be represented by P, and Q is twice the measure of R, which we said equal P, or be represented by P, and that's all going to add up to 180. So 4P equals 180. 180 divided by 4 is 45. So P equals 45. That means angle P is 45, angle R is 45, and angle Q is 90. So this also happens to tell us that this is a right triangle. Now for number 28, in EFG, the measure of F is 3 times the measure of G. And the measure of E is the measure of F minus 30. So I'm going to have G plus, for F I'm going to have 3G. And for E, I have F, and remember I just said F was represented by 3G minus 30. And that's all going to equal 180 degrees. So G, measure of angle F, I can put in 3G, and so measure of F, this may help you here, was this 3G minus 30. So looking at this, it's a little tricky to do when I'm trying to type here. G plus 3G plus 3G is 7 G's minus 30 equals 180. I'm going to add 30 to both sides, so 7G equals 210. And 210 divided by 7g equals 30. So angle G is 30 degrees. Angle F is 3 times G, which is 90. And E is 90 minus 30, which is 60. And that works. 30, 90, 60 add up to 180. Also makes it a right triangle. In 29 and 30, they want us to describe and correct the error. And equilateral triangles are all isosceles. So if ABC is an isosceles, then it is equilateral as well. No, because all equilateral triangles are isosceles, because isosceles says at least 2 of the sides are equal. But if only 2 of the sides are equal, it does not meet the condition to be an equilateral. So in this one, they said the measure of angle 1 plus 80 plus 50 equals 180. No, the problem is, let's say we had the measure, 2 here. It's the interior angle. So you could have said the measure of 2 plus 80 plus 50 equals 180. Or you could have said that the measure of angle 1 is equal to 80 plus 50. So on number 30, they kind of mismatched the theorems they were using. For number 31, which of the following is not possible? An acute scalene triangle, where you can have a triangle with 3 non-equal sides and all of the angles are less than 90, so that's possible. An obtuse isosceles triangle. Well, you could have a triangle that had sides of like 30, 30, and that would make 60 and 120. So you can have an obtuse isosceles triangle. A triangle with 2 acute exterior angles. No, you can't have that, because if you had 2 acute exterior angles, that would mean you would have 2 obtuse interior angles, and you can only have 1 obtuse interior angle. So it's B. And an equal angular acute triangle, all equal angular triangles are also equilateral, but if they're equal angular, each of the angles equals 60 degrees, so they are acute. The one you cannot have is B, a triangle with 2 acute exterior angles, because once again, that would mean that 2 of the interior angles are obtuse. Okay? And we'll do these. In exercises 32 through 37, find the value of x and y. Okay? So sometimes you have to find things that aren't what they're asking for in order to do these. So this angle here, that I'm not sure whether I need or not, but I'm going to do it right now, is going to be a linear pair to 75. So that's 105. Okay, so y has to be equal to whatever left over. So 180 is what you start with. You subtracted 43, you subtracted 105, and you get y is equal to 32. Now, here, you had that this was 105, but these lines are parallel, so 43 and x are alternate interior angles. So I didn't even have to do that. There might have been a shorter way to do y. I didn't even realize the line said they were parallel. So x is 43. Okay? So let's look now at these. These are 2 parallel lines cut by a transversal. So 118 and x are corresponding. It might be hard for you to see this, so let me draw a little bit more of a line here. So if you imagine the line continuing that way and continuing that way, that might be a little bit easier for you to see that x and 118 are corresponding. So x is 118. Okay, now this doesn't help you with anything parallel here. So this is 118. This other angle inside there, 180 minus 118 is 62. That's that little angle right in there. So if you start with 180, you subtract that 62, and you subtract 22, you get 96. So y equals 96. Okay, more fun. We got no parallel lines here, but we have, this is a right angle, that's 20. So that's going to be 70. Okay? I'm just going to find a bunch of stuff here. If this is 70, then this part above it is a linear pair to it. It's 110. Okay? So 110, and then that's 70 as well. So 25 plus x plus 70 is 180. So 180 minus 70 would be 110 minus 25. So x equals 85. So continuing on, sometimes you just start finding things to figure out what you can figure out. This is 90, so that's a linear pair. That one's also 90. This is 70, this is 110. X we said was 85. So this other part of the linear pair there is 95, because 85 plus 95 is 180. So I don't know though if we learned this yet. I mean, I would assume you know this from a prior grade level, but since this is a quadrilateral, that's all going to add up to 360. So I apologize if there's a better way to do this that I'm not seeing right now, or if you have not learned yet that a quadrilateral adds up to 360, but then I get y is equal to 65. And I was talking while I was typing into the calculator, so I'm going to just check my math there. 95 plus 110 plus 90 plus 65 is going to equal 360. Okay, once again, we have some parallel lines here. That's kind of exciting. So, parallel lines cut by a transversal. Okay, so this amount and 64 are consecutive interior. So they're going to add up to 100. They're going to add up to 180. So 180 minus 90 is 90. And then 90 minus 64 means this little bit here is 26. Okay? Now I can also find x, because 64 and x are going to equal 90. So 90 minus 64 is 26. And then y, I can see here, these are actually going to be similar triangles. I'm talking to myself. So that's 64. Okay. Now, for number 36, I'm having so much fun here. I don't know if you're having fun, but I am. Okay, so this is 47. That's 15. So this other angle here, 180 minus 47 minus 15. Oops, did something wrong here. 180 minus 47 minus 15 is 118. So if this is 118, then x is a linear pair to it. So 180 minus 118 is 62. X and Y are going to add up to 90 because then plus the right angle equals 180. So 90 minus 62 is 28. So X is 62, Y is 28. And then let's see what we can do here. This is 35. So 90, using the correlate, minus 35 is 55. So if that's 55, then this other angle here, because they're a linear pair, is 180 minus 55. I mentioned that I love these. It's like one of my favorite lessons. I'm probably finding more than I need to and going about it some long way, and you'll tell me there was an easier way to do it, but I'm having a lot of fun here on a Sunday. So this is 125. So 125, 18, and Y have to add up to 180. So 180 minus 125 minus 18 equals Y equals 37. Okay? And then for X, I need that little bit left there. So 18, Y, and X are going to equal 90. So 90 minus 18 minus 37 is going to leave X. And X is 35. So I hope this helped a little bit. I'm sorry that I am not there with you to go through these problems. As I said, you are welcome to come to another class today, periods 3 through 6. Remember that also to come by and get your Chapter 3 test. If you're going to be taking a retake, I can also went through this weekend and can tell you kind of what you need to get to next grade, or tell you if there's no chance of your grade going up. So say you're sitting at like an 83, even getting 100 on a test retake in many cases is not going to be enough to get you up to the next grade. But I miss you all, and I will see you very soon.